In this question, it is given that f of x is equal to 6x square minus 3. To find the zeros, we take f of x equal to 0. So, 6x square minus 3 is equal to 0. Now, we look for the common factor. The common factor is 3. So, taking 3 as common, we get 3 into 2x square minus 1 is equal to 0. Bring this 3 to right side, we get 0 by 3, which is equal to 0. Next, transpose this minus 1 to right side, we get 2x square is equal to plus 1. Transpose this 2 to right side, we get x square is equal to 1 by 2. To find the value of x, take square root on both the sides. That is x is equal to plus or minus square root of 1 by 2. Since square root 1 is equal to 1, we get x is equal to plus or minus 1 by root 2. Therefore, the zeros of the quadratic equation are, that is, zeros of 6x square minus 3 are plus 1 by root 2 and minus 1 by root 2. Let one zero be alpha and another be beta. Now we find the sum of zeros, that is alpha plus beta. Substituting the values of alpha and beta and simplifying, we get plus 1 by root 2 minus 1 by root 2 is 0. Next, we find out the product of zeros, that is alpha into beta. Substituting the values and simplifying, that is on the numerator 1 into minus 1 is equal to minus 1 and the denominator root 2 into root 2 is equal to 2. So that we get minus 1 by 2. Next, we find the sum and product of zeros directly from the quadratic equation. Given is f of x equal to 6x square minus 3. We rewrite it as 6x square plus 0x minus 3. Comparing this equation with the standard form, that is ax square plus bx plus c, so that we get a, b and c values. A is equal to 6, b is equal to 0, c is minus 3. Sum of zeros formula is minus b by a. Substituting this b and a values, we get minus 0 by 6, which is equal to 0. Next, we find out the product of zeros. This formula is c by a. Substituting c and a values, we get minus 3 by 6, which is equal to minus 1 by 2. Since the sum and product of zeros obtained from the quadratic equation and from the zeros are equal, hence the quadratic equation is verified.